Hello Limis, welcome to part 2 of our factorization lesson. Today we're diving into the difference of two squares, so we're learning to factorize the difference of two squares. So in today's lesson, we're going to learn to factorize the difference of two squares. So what is the difference of two squares? This is when two binomials which are the same but differ in sign are multiplied together. The product is the difference of their squares. So remember, a binomial is basically a mathematical expression with two terms. So you've got an expression with two terms, but two of them, okay? So those are binomials and they look a little something like this, okay? So the difference of two squares is factorized as follows. You've got something that looks like this. So x squared minus y squared, and then you basically have a square root of each term, and then this is what you get. You only factorize using dots, okay? Dots is basically like an abbreviation of difference of two squares. So instead of saying difference of two squares all the time, we can just say dots, or some people say DOS, right? Only factorize using dots if the squares are separated by a minus sign. You'll see what I mean in a second. So firstly, we've got something called square numbers. Square numbers are numbers you get when you multiply a number by itself, all right? For example, 2 times 2 is equal to 4, so 4 is a square number. 5 times 5 is 25, so 25 is a square number. So a square number is a number whose square root is a whole number with no remainder. So if I want to find the square root of 25, it's going to give me 5. The square root of 4 is going to give me 2. So if I basically have a square root of that number, I'm going to get a number that is just a whole number that's not a remainder. So that's how you know if a number is a square number. This is important because when we're working with difference of two squares, we're working with square numbers, okay? So this is a list of square numbers up to 12, up to 12 times 12. So 1, these are all perfect squares, because when you square root them, they'll give you a whole number, they'll give you 1. So 1 is a perfect square because square root of 1 is 1. 4 is a perfect square because square root of 4 is 2, and so forth. So it's very important for you to be able to identify square numbers, because that's what we'll be doing when we're factorizing. We need to be able to identify whether or not this number is a square number in order to actually solve it and move forward, okay? I hope everything makes sense thus far. Remember, square numbers are just numbers whose a perfect square is a number whose square root is a whole number with no remainder. So these are perfect squares, correct? And remember, difference of two squares is when two binomials are the same and they just differ. They just, are unique in signs. So maybe one binomial has a plus sign and the other binomial has a minus sign. Let's move forward. So let's look at an example. We've got x squared minus 4. If we were asked to factorize this, okay, we would factorize it as follows. We need to check if the digits or variables are dots, okay? What does dots mean? Is it a difference of two squares, okay? So let's look at our variable. If I were to square root x squared, would I get a whole number or a whole variable without a remainder? Yes, because if I'm square rooting x squared, I just get rid of the squared and I just have x on its own. So yes, this is actually a perfect square. If we look at 4, is that a perfect square? Yes, because if the square root of 4 is 2, right? And another way to identify dots is if there's a minus sign. There's a minus sign in the binomial, okay? If there's a plus sign, you can't factorize using dots. So both terms are perfect squares. Now, the second step, you write down two sets of brackets with a plus sign and a minus sign. This is us now factorizing something that looks like this, okay? Factorizing difference of squares. So we've got two brackets, one with a minus sign, one with a plus sign. and then you add the square numbers in each bracket. Okay, so remember, the square root of x squared will give us x, and the square root of 4 will give us 2. So you've got x minus 2, x plus 2. This is how you solve. You basically solve using the difference of squares or dots to make it easier, right? Let's keep going. Then we've got 4x squared minus 100. So again, you check if the digits or variables are dots. The square root of 4x squared is definitely a perfect square, and this is definitely a perfect square. Okay, so both terms are perfect squares. Then you write down two sets of brackets to factorize this. Again, you know you're going to be factorizing using dots because there's a minus and both terms are perfect squares. Okay, so then you've got your brackets with the minus sign and a plus sign. Check for highest common factor first. Okay, sometimes in this case, when you've got, remember, we don't forget about our factorization by taking out a highest common factor. We don't just throw it away once we learn about dots. We still need to try and find a highest common factor if you've got something like this. So the highest common factor here is 4. And so this is what you will have left. You will have 4x minus x squared minus 25. My bad, that was a mistake. X squared minus 25. Then we factorize. Okay, now we factorize. The 4 still stays outside, but we need to factorize the x squared minus 25 with our brackets x plus 5, x minus 5. And this is the final answer. So you still have to check for a highest common factor. The reason we didn't check in the previous example is because it was just x squared, and so there was no x in the other term. All right, let's move forward. We've got 81x squared minus 121y squared. Again, we can check for a common factor, but there is no common factor here because 81 is a prime number, so we just move forward, okay? Check if the digits or variables are dots. 81 is a perfect square. 121 is a perfect square. There's a minus sign between them, so yes, we can factorize using dots. Both terms are perfect squares. Second step, write down two sets of brackets with a plus and a minus sign. There we go. Then we check for a highest common factor. There is none. Then we factorize. 9x plus 11y, 9x minus 11y. And this pretty much checks out. It makes sense because if we find the x root of 81, x squared, it's going to give us 9x. We're going to get 9x. And then the square root of 121, we've got 11. Square root of y squared is in fact y. So we're basically just factorizing dots, and what we come up with is basically the square roots of the numbers. I hope that makes sense. And remember, when we spoke about factorization, we spoke about how when we've already factorized and we have the brackets, if we distribute within the brackets, we go back to the very same place that we started. So if you were to try to distribute this, you would still get the same answer. So here are a couple rules when it comes to factorizing using dots. You only factorize using dots when there is a minus sign between the terms. Only factorize using dots when the numbers are perfect squares. So you don't factorize, for example, if you have something like this. If you've got an x squared plus 4, you can't factorize using dots because there's a plus sign. Yes, this is a perfect square. Yes, that's a perfect square, but the plus sign disqualifies it. All right? Let's look at a couple examples together. Alrighty, so for number 1, I'm going to start by looking for a common factor. Between 7 and 63, I've got 7 right there. There's x cubed, there's an x, okay, 7x. Now I've got x squared minus 9, right? Sorry, that is a 9. Okay, cool. We need to move forward. We've got 7x, but I can see that this is dots. So I have two brackets, and one has a plus sign, one has a minus. Square root of that is x. 9 and this is essentially my answer. And then for 2x minus 8, let's look for a common factor, 2, and then we've got 4. Then we see, oh hey, this is dots, right? So we've got 2 brackets plus and a minus, square root of that is x, and then square root of 4 is 2. And then we can't simplify this any further, and this is our answer. Then we move forward to number 3. Okay, let's look for a common factor. Definitely 10 and the b. So it's 10b. Now we've got a squared minus 100. Remember, when you're taking out the common factor, it's just a matter of dividing the term by the common factor to get what's in the bracket. Okay, this is a perfect square. This is a perfect square. There's a minus sign. So yes, that is in fact dots. So we've got 10b, then we have our 2 brackets, one with the plus sign, one with the minus, alrighty. And then this is going to be a, this is going to be a, 10, 10. And that is our answer. Let's take a look at number 4. Okay, we've got 8 to the power, we've got x to the power of 8 minus 256. I must mention something that I did forget to mention. It is also dots when the power, basically the exponent of the variable, is an even number. An even number. So if it's an even number, it's still dots. I know you're probably used to a 2 there, but in this case we've got an 8. It's still an even number, so we can actually still, you know, factorize. So we've got x4 minus, x to the power of 4 minus 16, x to the power of 4 plus 16. So I basically had to find the square root of 8 to the power of 8, x to the power of 8, the square root of 256, and this is what I got. I can see that this is dots, but this is not, so that will stay the same. Okay, so let's factorize this because it's dots. Okay, so 2 brackets once again, x, that becomes x squared, that becomes x squared, minus 4 plus 4. And then this bracket remains the same because we cannot change it. It's not dots. We can't factorize. And then we see, okay, we found ourselves with another dots. Okay, this is not dots because it's got a plus sign. You only factorize, you know, using the difference of squares if there's a minus sign. So this is my, you know, dots. So now I've got x minus 2, x plus 2, because I'm factorizing this. Then the rest of the brackets remain the same because I cannot factorize them any further. And this is a long answer, but this is the answer. You have to factorize until the very last step. You have to simplify until the very last step. If you see that you can still factorize this using dots, then you keep going. And then this is pretty much what you have. All right? All right, my Limi, thank you so much for tuning into this lesson. I hope that this helped you. And if you have any questions, please do write in the comment section. Don't forget to like, comment, and subscribe. And I'll see you in part 3.